In this video we're going to look at how conditional probability can be used alongside tree diagrams and two-way tables. In the previous video we introduced the idea of conditional probability and we discovered the general multiplication rule for probabilities, which says the probability of A intersect B, or the probability of A and B happening, is the probability of A happening times by the probability of B happening given that A has occurred. So we're now going to consider the problem of removing without replacement 2 balls from a basket containing 10 identically sized balls, 6 of which are coloured red and 4 of which are coloured blue. And we're used to the idea of drawing tree diagrams to illustrate a problem like this, to show how the experiment can continue. And we can put in the probabilities fairly easily. Probability the first ball will be red is 6 out of 10. The probability the first ball will be blue will be 4 out of 10. Now if the first ball is red and the probability of the second ball is also red is 5/9. And the probability that the second ball is blue is 4/9. And those, of course, are conditional probabilities. We've got 5/9 is the conditional probability that the second ball is red, given that the first ball was red. The 4/9 is the conditional probability that the second ball is blue, given that the first ball was red. And those go on our diagram like that. Similarly, if the first ball is blue, then we can say that we have the probability that the second ball is red is going to be 6/9, and the second ball is blue with probability 3/9. And again, those are conditional probabilities. We've got 6/9 is the probability that the second ball is red, given that the first one was blue, and the 3/9 is the probability that the second ball is blue, given the fact that the first one was blue. So we can now say then, using the multiplication rule, the probability we get a red for the first ball and a red on the second ball is going to be the probability we get a red on the first ball times by the probability that we get a red on the second, given that the first was a red. So the probability we get red 1 and red 2 is 6/10 times by 5/9, which gives me 1/3. Similarly, the probability I get a red then a blue is 6/10 times 4/9, which is 4/15. The probability I get a blue and then a red will be 4/10 times by 6/9, which gives me 4/15. And finally, the probability I go blue then blue is going to be 4/10 times by 3/9, which gives me 2/15. Now it's worth noticing that the general multiplication rule for probabilities, which we had in the form probability of A and B, is the probability of A times by the probability of B, given that A has occurred, can be rewritten to give me the probability that B happens, given that A has happened, is the probability of A and B divided by the probability of A. Or equally well, it's the same thing as the probability of B and A, given that, divided by the probability of A. Now this formula for the probability of B given that A has occurred can be useful in calculating conditional probabilities that are not immediately obvious from the context. Now the key to using this formula is to carefully interpret what the event B and A actually means. And we'll see that in the forthcoming example. So 2 balls are taken without replacement from a basket containing 10 identically sized balls, 6 of which are coloured red and 4 of which are coloured blue. Find the probability that 2 balls drawn are the same colour. Find the probability the 2 balls are both blue, given that the 2 balls obtained are the same colour. Now part A we've done almost all the work for already, so we've seen how we can represent this experiment by a tree diagram, and we've worked out the probabilities for each of the branches in the tree. So we can now answer part A very quickly. The probability that we get 2 balls which are the same colour is the probability that we go red red or we go blue blue. So that is, from the tree diagram we've already drawn, 1/3 plus 2/15, which gives me 7/15. Now for part B, we want the probability the 2 balls are both blue, given that the 2 balls are the same colour. Now this is by no means obvious, so we're going to use the conditional probability formula. So the probability we get 2 blues, given that the 2 balls came out are both the same colour, is the same thing as the probability of getting 2 blues and 2 balls which are both the same colour, divided by the probability we get 2 balls which are both the same colour. Now the probability the 2 balls are the same colour we know is 7/15. What does it mean to say the 2 balls are both blue and the 2 balls are both the same colour? Well, if we know the 2 balls are both blue and they're both the same colour, that certainly means we just know the 2 balls are both blue. So that event, the probability of the event 2 balls are both blue and they're both the same colour, just simplifies to the event the 2 balls are both blue. So our conditional probability is the probability the 2 balls are both blue divided by the probability the 2 balls are both the same colour. Probability the 2 balls are both blue is 2/15. The probability the 2 balls are both the same colour is 7/15. So our conditional probability is 2/15 divided by 7/15, which just gives me 2/7. Now, in example 2, we've got in a college, all students must opt for one and only one option from art, music, drama or sport. And the table below, or the table to the side, shows the options made by the students at the college for this academic year. So we can see, for instance, that 12 male students decided to do art and 22 female students decided to do music. Now when we've got a two-way table like this, it is well worth our while putting in the row totals and the column totals. So we've got 120 males altogether, and we had 110 females altogether, and adding those two figures together tells us that there were 230 students in the college altogether. And now we can do the subject totals. So we had 56 students doing art, 30 doing music, 30 doing drama, and 114 doing sport altogether. So, find the probability that the chosen student chooses sport. Well, that's easy. We had 114 choosing to do sport out of the 230. So the probability for part 1 here is simply 114 over 230. For part 2, find the probability the chosen student chooses music given that the student is female. So at this time we're restricting attention to the 110 females, of whom 22 did music. So we've got a probability of 22 out of 110. And for part 3, what's the probability the student is female given that the student is choosing art? So in this case, we're restricting attention to the 56 students who are doing art, of whom 44 are female, so our probability is going to be 44 out of 56. For part B, we're told we're going to pick 2 students who are picked at random from the college. Given that the 2 students are both male, find the probability that they both do sport. So we are restricting attention to the 120 students who are males. We want the probability that both of these 2 male students that we're choosing are going to do sport. So, using the multiplication rule, the probability they both do sport is the probability the first one we choose does sport, times by the probability that the second one does sport, given that the first one does sport. The probability the first one does sport, well, we've got 85 male students doing sport. We know that we're only choosing from the male students, so the probability the first one does sport is 85 out of 120. The probability the second one does sport, given that the first one does sport, and given that we're only choosing from the males, is going to be 84 out of 119. So we've got the probability that both do sport is 85 over 120 times 84 over 119, which actually ends up giving me a half exactly. And for the final part of the question, we're going to pick 3 students at random, are picked from the college. Given that the students chosen do sport, find the probability that at least one of them is female. So in this case, we are restricting attention to the 114 students who do sport. We can certainly say the probability we get at least one female is 1 minus the probability we get 3 males. Now we're restricting attention to the 114 students who do sport, of whom 85 are males. So the probability that all 3 that we get are going to be male is going to be 85 over 114 times by 84 over 113 times by 83 over 112. So the probability at least one is female is going to be 1 minus 85 over 114 times 84 over 113 times 83 over 112, which gives me 0.589. So have a go now at these 2 questions. Pause the video and have a go at them, and take your solutions along then to your next lesson. And that concludes our look at conditional probability with tree diagrams and two-way tables.